Today we are going to look at limit of the function f of x multiplying g of x. All right, in my previous video we did look at limit of standard function, and this is one of the standards of limits that we are going to look at. So here what it means is you'll be given a limit, and then you have two different functions to solve to find their limit on the same question. So mostly those that we did previously, you have just one single, maybe f of x or g of x, then the limit of, say, the limit of f of x only, all right? And then here they've given us what the limit of f of x and g of x at the same time. So what do? The expression is like this: the limit of f of x times g of x as x approaches a certain value a. How do you do this? It's very simple, okay? The way is very simple. So all you need to do is to split them into two, all right, and find the limit of both of them separately. All right, when you are done, then you multiply them. So what I mean is, if you take the limit of the first one, which is the limit of f of x as x approaches a, times, then you find the limits of the g of x as x approaches a. All right, then you find your solution and then you go your way. This is the simple way of finding the limit of two different functions, okay? So the first thing that you have to do is to split them into two and find the limit of that particular function separately. All right, you find this one with the same x value, which is it is approaching. Then you find for this one too. Then you multiply the solution that you have. So let's take an example, a quick one. Okay, how do we deal with this? All you need to do is to take them separately. So here, as x approaches 2, all right, so all you need to do is to take them separately. So the limit of the first one, which is this, as x approaches 2, times the limit of the second function as x approaches 2. Okay, so now the next thing is to just substitute the value of x into the functions. Okay, so here we have 2 plus 3 times the second one, which is what, 2 squared minus 5. Okay, now the first one will give us 5, and then times the second one, which will give us what, 2 squared. We have 2 squared, which is 4, minus 5, we have minus 1. Okay, so now when you multiply 5 by minus 1, you have what, minus 5. Okay, so this is the limit of f of x times g of x. You know, you've been given two different functions and then you are asked to find the limit of both of them. So what did I do? All you need to do is to separate them. All right, you have the first one and then multiplying the second one. Okay, both functions, the second one, but then you insert the limit in both of them separately. After that, then you multiply the results. Okay, and the example here demonstrates the explanation of that, which is what we have the limit of one function and then another. All right, so you separate them, you find the limit of each, and then you find the limit. After finding the limit of each of them, then you multiply the results, then you have your final results. Now the next thing that we are going to look at is the limit of rational functions. Okay, what does the limit of rational functions mean? That one, if say you have a function f of x which is equal to a certain function which is g of x over h of x, okay, and you are asked to find the limit of f of x, how do we go by it? So this is what is going to happen. We have a limit of f of x as x approaches a certain value a, which is equal to, all right, whereby what, f of x is equal to what, these two functions, okay, which is g of x and then h of x. How do we find the limit of f of x? Now what you have to do is to find the limit of each of them, okay? So you take the limit of the first one, which is what, the g of x as x approaches a, all right, dividing the limit of what, the limit of h of x as x approaches a. After that, then you divide the values and then you go your way, provided the limit of h of x will not give you 0. All right, if the limit of h of x or both is not giving you 0, then it is possible. But if it is so, if the limit of h of x will give you 0, then you will have to, you know, simplify the two functions to get a very simple function before you can deal with what the limits and the limit aspect of it. Okay, so what I mean is, if for instance the limit of h of x as x approaches a will give you 0, what do you think will happen? This over here will give you what? Will give you an undefined solution. Okay, or both of them, if they will give you 0, then working with it will be very difficult. So what you have to do is to divide them. Okay, make sure you you simplify the expression u of x and then what, h of x, before you insert the limit in the results that you'll be obtaining. Okay, so when you insert the limit in the results that you'll be obtaining, then you what, you do the limits and then you have it your way. So we have an example here, which is what, if you have a limit of two different functions, which is x squared minus 1 over x plus 1. All right, as x approaches -1. All right, so over here, when you look at it very well, you realize that if I should put this -1 here, it will turn the function, the denominator, to 0. And if it turns the denominator to 0, it will cause all of this expression to be what? Undefined. Okay, so the solution to this problem would be that I will have to simplify the whole of this expression first. Okay, after expressing that one, or after simplifying that one, you realize that finding the limit will be very simple. So this is how it you do. So when you look at the expression very well, we have difference of 2 squared in there. All right, so when you check x squared minus 1, we can express it in difference of 2 squared, which will give us x minus 1 then x plus 1, which is what, the difference of 2 squared, and then x plus 1. All right, close it. All right, so you realize that this will cancel that, and it will be left with the limit of x minus 1 as x approaches -2. So from here we can insert our -1 into the expression. Now we have -1 minus 1, which will be giving us what? -2 as our answer. Okay, now let's take one more example and then we'll call it a day. Now, having gotten this answer, that would be what, the short explanation of the limit of a rational function. So if the rational function, you realize that the denominator will be giving you 0, don't go straight forward and insert the limit in the expression. All you need to do is to simplify it, just like in this example. When I put this -1 here, it will turn this one to 0 and it will cause the whole expression to be undefined. Okay, so you have to what, first of all simplify it, and then you do your substitution, then you have your way with it. So this will be the end of today's lesson. Okay, if God permit, we will look at the limit of infinity. All right, the limit involving infinity. So don't forget to subscribe if you haven't, share, like and comment. Okay, because the comment means a lot to me. Have a nice day.